Welcome back, MEGN 300. Today I'll be walking you through how to build the VI for your audio capture lab. This should help get you well prepared before you come into the lab for the first day so that you can focus really on getting the hardware and the software to be communicating correctly, since now you're getting a chance to do things hands-on. So the first thing that we want to do with this, or really that we have to do before we can build the VI, is to make sure that you have some helper VIs downloaded. If you go to the Canvas page for this assignment, you will see this link, DacVis. There's a little note that says extract these DacVis to your folder on the local scratch for your machine so that you're able to use them in the lab. It's very important that you save them on the local scratch so that they're stored on the local drive. You do not want them on the desktop or at a network drive because of the latency in the network and the communication back and forth between your VI, the audio capture VI, and these helper VIs that you're going to be using and communicating with the DAC. There's just too much lag and things will break. So be sure to save them on your local scratch drive. I've done that here on my local machine just to simulate being in the lab. You can create a little folder based on your initials, and then you just extract out the DacVis folder. Within the DacVis folder, we're going to see 3 different files: an analog acquisition, data acquisition VIs, and then the LabVIEW LLB file. So we'll go ahead and close out this, since we know that we have them saved in the right place. Let's plan out our VI. The first thing we're going to have to do is set up the DAC. Then we're going to collect the data from the DAC and build our waveforms. And then we're going to save the data. I have my contact cell open just because I have enough space on the screen. It's kind of handy to leave it here. If you want to turn it on or off, it's again controllable through the little question mark tab on the top right. So the way we're going to collect this data is we're going to use the waveform, not the waveform, excuse me, we're going to use one of those helper VIs that I just mentioned. So right click anywhere on the screen and go down to select a VI. I've already navigated to the folder where my DacVis are, and we want to select the analog acquisition VI. Should open up, allowing you to drop the icon anywhere you'd like. And now you'll notice that we have a drop-down menu. Here we get multiple options here, but what we want is the multiple channel, multiple samples. Multiple channel makes sense because we have a left and right audio, but multiple samples are required simply because of the speed of data recording and communication with the computer. So what we want to do is we want the DAC to record a whole bunch of samples for us and then put them together in a package to send over to your computer, to this VI, in little chunks, or big chunks, I suppose, because the DAC is very fast at communicating, well, at recording the data, of course, and then it can store that information on its internal memory up to a point and send it over in batches to your computer. So you don't have the latency of communicating between the DAC and the software that could potentially break things. So here we are, multiple channels, multiple samples. By clicking on it or hovering over it, we can see the context hub on the top right, and we see on the left side of the icon, we'll be inputting our physical channels, the number of samples, and the rate. In order to get on the out, we'll need the data. So here we go, we can just hover over the DAC MX physical channels, and we'll need to create the inputs for this. So right click, create constant, and then if you highlight over all of it and drag it up here, you can put it under your Set Up the DAC section. We'll need 2 channels, so we'll start with index 0, and we'll hover over until we get the little finger to click and drop down. And now we need to select the physical channel associated with either our audio left or our audio right. So the first portion of this will be your device name. For me, this is again my local machine, so it is not set up the same way as the lab. But for my local machine, I have a simulator device, PCI 6221. Now, you obviously don't want a simulated device, you want the real device. And that should be named Dev1 for all of you. If for some reason you don't see Dev1 or you have some question about which device it should be, feel free to ask questions in the lab. That's why we're there to help. But you select the device should be Dev1, and then you select the channel. So AI0 would be analog input 0. So notionally, we'll select analog input 0 here. Try and expand this out so we can actually see the channel names. Now we want to increment to the second channel, and this would be whichever analog input you have associated with the other audio signal. So if you're just using the top two on your DAC card, then, or excuse me, your input device, then that'd be analog 0 and 1, but you can use any of the 8. For number of samples, we can create a constant to set the number of samples that it will take before sending it over to the computer, and we want to set that at 5,000. And then finally, we'll also need to set a rate, a sample rate. So we can right-click, create a constant for a sample rate. Here we'll set it at 50,000 and drag that over. Now, in the spirit of good coding, let's label everything, start our comments. So this is going to be physical channels. This is number of samples. And this is our sample rate. Okay, great. We're all set up to collect exactly 5,000 samples one time, which is not what we want to do. 5,000 samples that are at 50,000 hertz would give us 1/10 of a second worth of music. So we want to do this multiple times. In order to do that, we'll create a while loop. So right-click, go to Structures, and While Loop. Select it, drag, create a big box. We're going to do some other things in here, but make sure you include the multiple channel, multiple sample VI. Go ahead and let go, creating yourself the while loop box. And the first thing we should do is create a stop condition. So hover over loop condition in the bottom right, right-click on it, and create a control. Here we have a stop control. Now what we need to do, if we look at our helper VI for a second, we see that we have data coming out. Well, we have multiple channels worth of data in some form of an array coming out. So what we need to do then is split that up into left and right channels. In order to do that, we will use the index array function. So right-click, go to Array, and go to Index Array. What this will do is it will take the data array and split it into left and right channels. Now right now, we only have one out element, but we need two out elements. So we're going to click the bottom of the icon and drag it down. So we have two out elements. Now we can connect the data out into the n-dimension array in. And we see that that is a good connection. There are no issues in data types for our lines. Now we have a left and right channel, but again, we only have one sample worth. So what we're going to have to use is our shift registers in order to store the data and move it through the while loop. So go to the right side of your while loop, right-click, add shift register. We'll need one of these. You can click on them and shift them. So you can click on the shift register, maybe. Apparently not. Now you can, and move them up and down. But you're going to need two of them. So right-click again, add another shift register, and we'll drag this one way down here. So we'll have one for our left channel and one for our right channel. But we need to do something with our array of data. If we just use this shift register like this, if we just drag this element over into the shift register, we're just moving data, but we're not appending it to anything. We're not aggregating the data between the while loops. So what we want to do is we want to use the append waveform VI. In order to get to that, you're going to right-click, go to waveform, go to analog waveform, and go to append. So this is the append to waveforms VI. Go and click on that, drop it on your menu, or excuse me, on your inside your while loop, hit Control, click on it, and drag down so you have two of them. So I'll just talk through one of them real quick, and we'll do the exact same procedure to the second. If we look at our context help, we can see that we have a waveform A and a waveform B, and then a waveform out. So it's going to append A and B together. It's going to add A and B together. If you're confused about which is which gets placed first, read the little info. It tells us that it appends waveform B to the end of waveform A. So every time we take our chunk of samples, our 5,000 samples rather, we want to add that to the end of the existing music so that we're not playing the song backwards in tiny little chunks. So for that, I'll take the element for one of my channels and I will drag it up to the waveform B slot on the append waveforms VI. I can go ahead and drop that or connect that line, connect that wire rather. So then I take the waveform out and I bring it over to my shift register. And now my shift register is bringing data. It's highlighted on both sides. It's bringing the data around the while loop. And I want to bring that shift register over to my waveform A. So it takes everything, adds the new material to the end. We have a complete array that goes through the shift register and is brought back and is used as the starting point for the new set of 5,000 pieces of data. We're going to repeat this for our second channel. So make sure again that it goes to waveform B, complete our shift register, and complete the loop, connecting the left side of the shift register into waveform A. We're not done yet because we have not initialized these shift registers. So what I'll do right now is I will take care of that. I'm going to right click on the shift register and create a constant. So this is the waveform data type that it needs. So I'll call this initialize. And here we have the initial date time, and then this value right here is our delta t. Now, here we have a problem. Our delta t is 1 second, but we're taking a sample rate of 50,000 hertz. So we're going to have some really messed up data, and we're going to have a ginormously long wave file with nothing in it, essentially. Spaced out data so far apart that it won't be playable. So what we need to do is we need to change this to 1 over 50,000, which is 2e to the negative fifth. There we go. So this will make sure that our shift registers are recording the data at the appropriate sample size and sample rate. We need this to apply to both. So I'll go ahead and go up to the top shift register and connect that wire down here, and we can use the same initialized waveform data type to get our loop going. Great. Now we have everything. We have, assuming we hit stop, we're going to have our left and right channels in waveform data type ready to go, sitting here at the end of our while loop. Let's save those to data. So if we right click, we're going to want to save a sound file. In order to do that, we need to go to Graphics and Sound, Files, Simple Write. So this is Sound File Simple Write. If you would rather not do that whole drill down, you can't remember quite where to find that, we can just right click and go to Search. And here we'll go to, well, Sound Write. And there we go, Sound File Write Simple. Click on that. It'll bring us to the correct place within the Functions menu, and we can just click and drag over a sound file write. Close that out. If we click on the sound file write, we can look at our context menu again. We see that we need a path, the data, and that's pretty much it. In order to set the path, we could hover over, right click, and create a constant. But we don't want to do that. We want to be able to dynamically change the path name to whatever we want every single time we run this file. So go ahead and right click, go to File I/O, go to File Advanced Functions, and go to File Dialog. So if we click on File Dialog, we can bring that over and we can drop that down. As soon as you drop it, it will open this menu. We want to write a file. and we want it to be either new or existing, which means you can overwrite the existing files. Click OK, and now we'll connect the path coming out of there into the path for our sound file write simple. Great. So let's do some labeling here. This will be write.wave file. This will be select path, including the file name, and we need to include .wav extension. This will help Windows recognize that it's a WAV file, so you'll be able to play it right away instead of changing the extension name later. But we can't just connect our shift registers over to the WAV file. We need to recombine our left and right data. And so in order to do that, I will right-click, go to Array, and we are going to build an array. Drop that somewhere outside of your while loop, extend it so that you have 2 elements, and connect each shift register, 1 per channel, into the array. And then you can connect the appended array to your simple file write, or excuse me, sound file write simple. And there you have it. You've now written the data to the WAV file. There are a couple things missing. First off, we haven't done a good job commenting our code, so let's go ahead and do that. This will be right here, is going to be split our left and our right channels. These will be appending arrays within the while loop. Here, we're going to recombine left and right channels. Great, so things are looking a little bit better in terms of commenting, so we can recall what things actually do, but there's one other, not really a problem, but awkward behavior that would occur right now, and that is if I were to hit run on the front panel, collecting data, the first thing that would happen is this file dialog would appear while it's still running before I've hit stop. In order to force this file dialog to not appear until after the loop is complete, till after I hit stop, we can use the error wires. So what I'll do is I'll connect the error wire from our multiple channel, multiple sample over to the error in on the file dialog. And that will force this dialog to wait until this while loop has completed. Okay, and that's it. That's your VI all ready to go for your audio capture lab. There are some additional things that the lab asks you for, such as some graphs, and I'll let you do that on your own, adding some graphs to the front panel. But other than that, I look forward to actually getting our hands dirty with this VI and the hardware in the lab, and good luck.